Day 10, we are coming towards the end of our 6-week course. And today we're going to be looking at network troubleshooting. If you were to ask me, I think that after the ability to communicate, network troubleshooting is probably basically troubleshooting is the number one skill that you need if you're going to be venturing in networking or if you're working in the industry. The reason being that most of our time is spent in what is known as BAU or business as usual. If you're not dealing with projects, and 90% of your work is going to be troubleshooting issues. And I have seen weird issues pop up. A good 60-70% of the times is not a network issue, but there is this notion that when things stop working in a business environment, networks are the root cause. And so everyone else will always come and say, network is not working. So it is your responsibility to not only defend your network, but to be able to demonstrate that it indeed is not the network. Now, I'm not one for playing hot potato with issues where you're trying to blame, infrastructure or server systems or applications. I'm more interested in how best you can get the application or the issue that is not working functional. So yes, this to me is the most exciting lesson because this is where we cover hands-on. Now I was trying to find a way that I was going to cover this module, and I figured, you know what, I might as well make it as hands-on as possible so that we can be able to not only configure, but we can then be able to, configure our lab. I'm going to be using Packet Tracer. So I would encourage you to, come along with me as I configure. And then we're then going to go ahead and break that particular lab. And then we're going to look at different tickets and then try and resolve what the issue is. And then we're going to be using some of the methodologies that we're going to look at in as much as troubleshooting is concerned. Now, there's no right or wrong answer on how to troubleshoot, but having a system or a method of coming to your root cause is probably going to help you get to the problem much more quicker. So Thursday's class will be our last class. If you got any questions, this is the time to ask me any questions. Send them in the chat. Send an email. My email is in the description below. I will be more than glad to answer. Some people have sent me emails. I'm in the process of responding and corresponding. So without taking too much of your time, let us begin. So I'm just going to start by sharing my screen. So we're going to be looking at two methods or two methodologies of troubleshooting. These are kind of like the recommended standards in the industry when you are troubleshooting network issues, because I don't know how I can say this, majority of your time is going to be focused on fixing issues, and your ability to troubleshoot is going to be very important. So let us look at the starting point. 90% of the times, if you have a ticketing system, someone is going to raise a ticket and say A, B, C, D is not working. They might raise it through a ticketing system. It might be a phone call, or someone might just walk into the network team and just highlight that something is not working. So the first step is the issue has been raised. Where do we start? All right. And the first step, as you can see, we need to gather as much information as possible. And when I'm saying gathering information as much as possible, the first thing is who raised the issue? What is the problem, right? What exactly is the issue? Is it applications not working? Is it the network being slow? Is it not users not being able to access the internet? So when you take in that first complaint that comes through, try and gather as much information. When did it start? When it started, what was happening. Were there any changes to the network? Because most of the times when a change has happened on the network, it could result in issues resulting because of that particular change. So being able to understand what time, when did it start, how long, is very, very important in your information gathering. This is before you even start thinking about how are you going to solve the problem. You're just trying to get as much information to try and figure out what could be the problem. Now, after you've gathered information, ask other users, who else is affected? Is it only affecting you, or is it affecting other people? When you ask such questions, what you're trying to establish is it just one particular user who's complaining that the network is slow versus everyone else in a department or everyone else in the office is echoing the same opinion? Because if you got more than 5 people complaining about the same issue, there's a very high chance that the issue is not related to a particular individual. The issue could be related to something else altogether. So when you then go in and troubleshoot, you have an understanding of what exactly you're basically dealing with. So in our flow, we have gathered information, we have asked questions. We need to figure out when did this start, right? Who else is affected? You are gathering your information. And as you start gathering this information, you start to hypothesize what could be the issue. Is it a switch issue? Is it a router issue? Is it a slow internet issue? Is it an application issue? And this is where you're going through all these scenarios. Is it A? Is it B? Is it C? Is it D? And then from there, you ask yourself, can you replicate the problem? Right? Is it a problem that you can replicate? Can you try and redo whatever is being experienced on the network to try and fix it? Because issues that you can replicate are sometimes easier to fix because you are able to identify. For today, maybe let me bring back I feel a bit empty in the fact that my face is not on the screen. So let me just try and change just so that we can have a conversation. Hopefully you can see. Okay, I'll just get this out of the way. All right, that's a bit better. All right, so you can see me and you can see the screen at the same time. So what I was saying is that when you look at the ability to replicate, right? If you can replicate an issue, it means that you are able to establish what was the root cause, and it's easier for you to fix because you're able to replicate it. I have found that issues that you can't replicate are the most challenging ones. Why? Because you're dependent on someone's opinion of a particular issue, and because you can't replicate, sometimes it's difficult for you to then come up with the root cause as to how best you can fix it. And if you can't replicate the problem, you try and identify the symptoms, right? We're just trying to gather as much information. So if I were to give you a basic example, when you are trying to fix a car, right? You wake up in the morning, you try and start your car, the car is not starting. What do, right? You either go and check for the battery to try and see if you got enough battery. And the usual method that we were taught when we were growing up is to press on the hooter. And if the hooter makes a sound, then there's a very high possibility that the battery is okay. I'm not saying the battery is okay, but there's a high chance that when the battery, when the hooter is making a sound, the battery is working. The next step is you probably turn on the lights. If the lights are coming on, then the battery's got some form of power of some sort. But if the hooter is not coming on and the lights are not turning on, then you probably have a battery issue. If everything else is fine on the battery, you probably go and look at the fuel tank and check if you've got enough fuel. So you ask yourself, when was the last time I refueled? When I refueled, what was the gauge trying to tell me? Does it have enough fuel? Does it not have enough fuel? So just think about the way that you would troubleshoot anything in your day-to-day and try and apply that in a networking context. The only difference is, like I said, you are trying to, there's a methodology that they basically recommend. So we have identified our symptoms. Let me just get my pen. We have identified our symptoms. Now we are trying to look at what changed. Did anything change on the network? And sometimes you might not just figure things out. And this is a step that most people usually don't take. Just take a step back, take a break, do something else, just to refresh your mind and reorient. Sometimes when you're too focused on a particular issue, you tend not to see the obvious. But if you take a step back and just try and think about the issue outside of the box of what you are narrowing down to be, sometimes you can find issues or solutions from doing that. I had a similar problem this morning. I've been not necessarily struggling with this issue, but things are not working as expected for the last day and a half. And I was dealing with a vendor who was in a different time zone to try and resolve this issue. And in the morning, I was a bit frustrated, So I decided, hey, man, I'm going to go for lunch. And I'm just going to take a break, clear my mind, and then came back from lunch, and lo and behold, the issue started working. You managed to find a solution. So this is the methodology. You don't have to apply it on a one-to-one basis, but it's always important to be able to get into a problem with an understanding of what it is that you're going to achieve. I told myself when I was starting in the industry, the moment someone calls me and tells me that there's an issue, I always try and think, what are the 5 possible issues that could be related to this? So if you call me and say, we're having slow performance on SharePoint, in my mind, I'm thinking, okay, fine. Is it a SharePoint issue? If it's a SharePoint issue, how do I verify? Is it a network issue? If it's a network issue, how do I confirm that it is a network issue, or how do I confirm that it's not a network issue? So as I'm working to go and fix the problem, in my mind, I'm trying to think, what are the 5 possible outcomes that could be a result of this particular issue? And I've always found that having an open mind kind of helps me, because I'm not necessarily narrowing down myself most of the times. I'm coming very open-minded, and then I take hypothesis, I run down that hole, see if I find something, I try something else, and I do the same thing. So this is one methodology. In the next one, I'm just going to look, it's almost similar to this one. The steps almost identical, but I'm just going to cover what the textbook basically recommends. This is a recommended troubleshooting methodology. If you read any Cisco books, they basically highlight. So this is the standard troubleshooting formula. Ticket comes in, collect information. We spoke about it in the previous slide. So collect as much information. When you collect that information, develop a hypothesis. So if someone is talking to you, if imagine someone comes to you and says, I feel stressed, right? Okay, you feel stressed. What's the issue? Then they narrate. Whilst they're narrating, you're starting to make a hypothesis as to what might be the root cause. You don't know what the root cause is, but you're starting to think about, possible outcomes. So you could probably think, okay, there is 1 possibility, 2 possibility, 3 possibility. Now, as you move to the next step, you're now testing the hypothesis. So if I was thinking that it's a network issue, I might issue the ping command, right? I'm going to mention things that we might not have discussed, in this course. We're going to cover some of these commands in the next lesson. So be sure you attend the next lesson, because I'm going to go into detail of the particular commands. So I can probably say, okay, fine, I'm going to ping to verify. If not, I'm going to trace, or I'm going to do an NS lookup, right? I'm trying to test the hypothesis. So if I do an NS lookup, I'm verifying if I've got DNS issues. If I'm doing a ping command, I'm verifying connectivity. Do I have connectivity to the respective device? When I do a trace, I'm trying to see how many hops and where am I stopping along my path. And then I can then narrow down where my issue is, right? For those that are joining us, I'm just going through these 2 slides, and then we're going to go into the actual configuration of a lab in Packet Tracer. And then we're also going to break that lab and then look at a normal ticket that would come on a standard day and try and gather as much information from that ticket as possible to try and figure out what our issue might be. So these are the only 2 slides that we're focusing on. And then the next thing, we're going into configuration. All right. So now you've got you test your hypothesis, you ping. If you can ping, it means that you have reachability. If you can't ping, it means that you have no reachability. You start figuring out, okay, fine. After I've done my ping, I'm going to do my trace. When I do my trace, I'm going to see where I'm stopping along the path. And I'm going to narrow down my focus on that particular element. And then after you've tested your hypothesis, you've found out what the issue might be, you're going to go to this step where you're going to implement your fix. So you're going to implement your fix. If your fix can be implemented during business hours, fantastic. Some fixes cannot be implemented during business hours because they might cause some form of outage on the network. So you might have to then schedule a change to do them after hours. We spoke about changes at some point during the course, and we say that change is a document that you present before a committee just to highlight what you are changing on the infrastructure, what the impacts are, and what the benefits are. So after you've implemented the fix, this is one step that people usually forget. Notify the user who raised the issue. Just because you've fixed something does not necessarily mean that the person who raised it has been notified. Because sometimes some users will decide, okay, I'm not going to do payroll, and you don't want anyone to not do payroll because people don't get paid. But someone might say, I'm not going to do payroll because there's an issue with payroll, right? I'm waiting for IT to come back to me. If you don't notify that payroll is now up and running, then someone might wait 2 days before they can do something about it. Or the ticket, if you're using a ticketing system or you're using things like ITIL for your service level agreements, you then have a situation where the ticket might breach SLA because you haven't notified the user. So notify the user. And the last step, another crucial step, is document your fix. I don't know how many times I've been down this road myself, where you fix something, you don't document, and then 2 months down the line, the same issue happens again. And then you're trying to say to yourself, how did I fix it the last time? And now you have to waste another hour or 2 hours just trying to come back to the same solution. And yet, if you had documented the issue, you could have resolved the problem much more quicker. I skipped a step. When you're doing your hypothesis, Google is your number 1 friend. Go online, search. There is no problem that you're going to encounter that someone has not encountered before. So go online, type in the errors that you're getting. You'll get some form of feedback coming back to you. Take that feedback, see how best you can implement it. Only thing I recommend is just read the entire forum. I don't know how many times I've been burnt in the past where you read half the forum and then you go and apply the command. And then when you read the other half, someone says, oh, by the way, when I did the same thing, I took out the entire network. And by that time, you have a network that is now entirely down because you have inputted the wrong commands. So don't take forums word for word. Hypothesize, look at different forums to basically try and get to your solution. So these are the troubleshooting steps. And, oh, sorry, I forgot. There are 3 methods of being able to resolve an issue. The first, they call it a top-down approach. Now, remember the last time we spoke about the OSI, and we said the OSI has got 7 layers, right? We've got the application at the top, and then you've got the physical at the bottom. So when you do a top-down approach, you are fixing or you're troubleshooting a problem starting from the top, starting from the application, trying to come downwards. right? So you start with, maybe go to google.com and see if you can get to the website. If you can't get to the website, you then go to the transport layer. From the transport layer, you go to the data link, to the network layer and the data link layer. That can work in some instances, but it also has its own challenges. In a typical car example, right? Imagine your car can't start, but you're checking the indicator. There's a very high chance that the indicator has probably got nothing to do, or you're checking your rear view mirror, or you're kicking the tires. The tires will have nothing to do with your car not being able to start. So top-down approach has got its own space. There is what they call the bottom-up approach. And bottom-up approach is you're starting from the physical layer, right? You're checking the network cable. If this is your PC, to the switch, you're checking the cable. If the cable is fine, you're checking the switch, you're checking the router, you're checking the routing protocol, and then you're going all the way up. Bottom-up approach. Or you might want to use what I call shooting from the hip, and that's my favorite. You're basically starting from the middle, right? So I can start with the ping command. And if my ping command returns a success, what it basically means that this entire layer is functional. Because if it wasn't functional, then things would not have worked. The best example that I can give is if you're suspecting that there is no electricity at home, if you turn on the light in one bedroom and the light is coming on, then that's an assurance that there is power coming in the house. But if you turn on the light in two bedrooms and the lights are not coming on and all the sockets are down, then there's a high chance that there's no power coming in. So just apply your logical common sense. But for me, I like I call it shoot from the hip approach. Right. And I think I've forgotten the name that they call it officially, but you're basically starting from the middle. And we are going to then go over and try and see this in action. So without taking too much of our time, let's go to the next slide. So this is our network diagram that we're going to be using for our troubleshooting. I thought maybe I should create the lab in advance, but I figured out, you know what? We all want to learn, so we're going to build the lab together. And we're going to configure the lab together so that in the process, you're also learning. So this is the lab. In our lab, we're going to have two PCs, one printer, one DNS server, and we're going to have a router. This is going to represent our WAN interface. I just need to put that. So this is our WAN interface. And then we've got to have a router on the other side. And then here, we've got a server that is going to act as our internet. So this is going to be our Google server. So this is our lab. We're going to be coming back and forth on this particular one. So to start with, I'm going to open up Packet Tracer. What do I want to do? Right, I'm going to open up Packet Tracer and I'm going to start from scratch. I'm going to delete this. Okay, so in our lab, we said we're going to have two PCs. All right, let me just go. So I trust you can see my screen. Okay, good. All right, so we're going to have two computers, 1 and 2. We're going to have a switch connected here. I think there are printers somewhere here. Yeah, we've got a printer here. And then we're going to have a server, which is going to be our DNS server sitting on this end. And then I'm just putting all the devices in the topology, and then I'm going to run the cables later. Right, and then we're going to have our two 4300 routers on either end. And then I'm going to have another switch sitting here. And then I'm going to have another server sitting here. This is going to be a web server. So this is going to be a web server. And then now we're just going to connect. All right, so let's go. Just auto connect. this to that, this to that. I'll probably do this quickly. It's just connection of devices, and then we're going to do the configuration. And there's no configuration, so we're going to configure it from scratch. So if you're going to follow through and if you're going to build your lab, you can be able to build it along with me, and you can probably pick the same devices, and we should be able to reach the same outcome. Okay, so now we have logically connected our network. We're going to start with our PCs. I'm just going to double click, and I'm going to go to the desktop, and this is where we configure the IP address of a packet tracer PC. So we said the first PC is going to have an IP address of 192.168.0.20. So PC1 is going to be .20 with a /24 subnet mask. Now we're talking about subnetting. If you are not sure about subnetting, we covered it earlier on. You can be able to go and have a look at that. We are going to use a default gateway of 192.168.0.1. All right, so I'm just going to pull back my, right, so this is what I'm referring to. So .20, .30, the printer is going to be .50, .1 is our gateway, that's on the router, and then .10 is going to be our DNS server. Just in case you might be wondering, you know, what am I referring to? Or if I've lost you somewhere along the lines. That's what I'm basically configuring. Right, so gateway is 192.168.0.1, and then our DNS server is 192.168.0.10. Okay, so that is configured, and then I come back to the desktop. I just want to make sure that my IP address is correct. I'm going to type the command ipconfig and just double check. So yes, my IP address is 192.168.0.20. Subnet mask is /24, and the default gateway is 192.168.0.1. Okay, so that's fine. Let's go to PC number 2. This is probably going to be a bit quicker. This is going to be 192.168.0.30. Subnet mask /24. Default gateway 192.168.0.1. And the DNS is going to be 192.168.0.10. All right, so that is done. Close that. Our printer, we are also going to give it an IP address. So we're going to go in fast Ethernet, static IP 192.168.0.50. And subnet mask is going to be 255.255. We don't need a gateway for the printer because it's not going to talk outside of our network. So it's going to talk locally, so we don't need the gateway. All right, printer is done. Let's go to our server. We're going to configure our server. The IP address is 192.168.0.10. That's 255. So that's the first part. We've configured the IP address. Now we want to configure the server as the DNS server. And you go onto services, you're going to find DNS. And we said DNS has got two types of records. Oh, sorry, multiple records, but we're interested in what is known as an A record. And an A record is basically associates a friendly domain name, which is an FQDN, with an IP address. So we said DNS basically resolves www.yahoo.com to an IP address of 5.5.2.2. So the DNS does that, and we call this record an A record, right? It's basically doing an FQDN, which is a fully qualified domain name, to an IP address. So we are going to do that. Right, let me just erase that. Okay, come here. So we're going to create a record for our internet server called google.com. Did I spell that correctly? Okay, google.com. And the IP address is going to be 8.8.8.8. So that's an A record. I'm going to add that. So when I type google.com in the web browser, it's supposed to resolve to 8.8.8, and it's supposed to go to our server that is sitting on the internet side. That's what you're trying to achieve. We're going to test that when we're done. And then I'm going to create a local SharePoint record for the purposes of our ticket that we're going to be looking at. So if I'm going to create another one called SharePoint.com, right? This is going to be our local record, and that is going to be on 192.168.0.10 because it's hosted on that DNS server. So it's acting as a DNS server plus a web server at the same time. All right, so we've added those two records. That is fine. And then the last part I'm going to configure on this side is the interface gig 000, which is facing the internal side of the network. I need to configure the gateway IP address, and then we're going to do testing. All right, so all right, I've got a question. What are the criteria in assigning a default gateway? There's no criteria, actually. You're just basically picking an IP address in your subnet that is going to be your IP address that takes you out of your network. Now, if you look at my diagram, the whole objective of a default gateway in this case is that this is our internal network, right? So this is internal, or rather this is our private network. And this part will be the public network. So you need to have a gate that takes you out. If this was my yard, right, I need a gate that takes me out of my house to the outside of my yard so that I can then go into the street and drive my car. So any network that needs to exit must have a gateway, and that gateway has an IP address. There's no hard-coded criteria. However, if you've been in the industry, there are two IP addresses that are usually used for default gateways, either .1 or .254. So either the first IP address or the last IP address. If you're dealing with a /24, yes, that's the most kind of common and standard ones, but there's no hard-coded rule. But at the end of the day, this is our gateway .1. So we need to configure it on the router. So I'm just going to erase this and then come back to our configuration. Okay, so where was I? All right, so we are going into our router and we're going to the command line. Sorry, we're going to the command line, and I'm just going to expand this to make it bigger. So we turned on our router for the first time. It's asking us if you want to auto configure. I'm going to say no. I'm going to press enter, and then I'm going to conft configure terminal for Cisco devices. If you're not aware, we'll probably cover that later. So our interface is interface gig 00. So I'm going to go into interface gig 00, and then I'm going to give it an IP address of 192.168.0.1 with a subnet mask of 255.255.255.0. And by default, sorry, Xavier, I hope I've answered your question. If I haven't answered you, please just ask me later on. By default, router interfaces are they're shut down on a Cisco device. So I need to do a no shut to bring the interface up. So our interface is now up. We need to test our network. So I need to go back and verify that everything is now working. So if I go to PC1 and I go into the command line, I should be able to ping my default gateway. Right, pinging my default gateway basically confirms that I have connectivity between my device and my router. So that's 192.168.0.1. I press enter, I'm getting a reply. So what is this reply signifying? What this reply is confirming is that from my PC, which is sitting here, this cable is working fine. This switch is working fine. This cable is working fine. So this is what I was saying earlier on to say, when you do a shoot from the hip kind of troubleshooting, you are simply saying, I started at the network layer, right? This is our OSI. And I started at the network layer. And because my ping worked, it means everything going to the data link and the physical cable was working fine, or is working fine, because I'm able to then ping from my host. So we have configured this side of our network, right? We can ping everything else is fine. Now we need to configure this part of our network. Right, and I said earlier on, we are going to be using an IP address of 10.1.1.1.0/30, and the /30 address has got two addresses. We have a .1 here and a .2 on this end, and we're going to use EIGRP as our routing protocol. We are going to advertise this network, and we're going to advertise this network. Once again, we're going to configure together, so I'm not leaving you behind. I'm just explaining what we're about to do, so that when you see me doing it, you're not wondering, what's going on. All right, so we configured gig 00. We need to configure gig 001 with our IP address. So the other thing that I recommend is put a description on your interfaces. So I'm going to call this internal network, so that if I'm looking at the interfaces, I can be able to try and figure out what's going on. All right, exit that interface gig 0/0/1, press enter. IP address is going to be 10.1.1.1.255.255.255.252. And description, this is going to be our one interface, and I'm going to do a no shut. Right, so I'm going to bring the interface up. Now, how do I confirm that my interfaces are now up and running? I type the command show IP interface brief, and I can see that my two interfaces, I'm just going to get my pen here. Let me turn that to be purple. Okay, cool. So I've got my two interfaces configured. They're up on the protocol. This one is down, and the reason why it's down is because the other side has not yet been configured. When I bring the other side up, this is supposed to go up. Otherwise, if this remained down, then I've got an issue to troubleshoot, but we're not yet going through the troubleshooting stage. We're just going through the configuration at the moment. So I've done the first side. I'm just going to go to the other side. I'm going to configure EIGRP. So the configuration of EIGRP is running as a routing protocol is router EIGRP. I'm going to use the autonomous system 1. If you're not sure what the autonomous system is, I might have covered it in the past. No, I covered it in the past. If you still don't understand, just send me a question on the chat and I can answer you. I can probably go into detail. And router EIGRP 1, we're going to advertise two networks. The first network is going to be 192.168.0.0, subnet mask 255.255.255.0. And then the other network we're going to advertise is 10.1.1.0, and the subnet is 255.255.255.252. Okay, so EIGRP is configured on the left-hand side. If I want to verify my EIGRP, I'll type Control-C. That takes me back to my enable mode, show IP protocols. There are two commands I can use. Oh, sorry, not two. Show IP protocols. There we go. So this confirms that EIGRP has been configured, and I'm running it on autonomous 1. And these are the two networks that are being advertised. So EIGRP is configured on this end. Very important when you're starting to troubleshoot, because these are the commands that you're going to need to be able to then figure out what's going on. All right, so the left-hand side is fine. Let's go to the other side and do our configuration. And I'm going to minimize that. Come here, minimize that, go to the second router. Right, so before I do that, I just want to just double check. So gig 00 on the second router is the one that is facing the WAN side, and then 001 is facing the LAN side. Right, so that's important. I just need to just make sure. Okay, so let's get that going. Go to the command line. Once again, expand this so that it is visible and we can see what's going on. I think this should be big enough. We don't want to auto configure. Press enter, enable. So conft configure terminal, interface gig 0/0/0 is the WAN side. So description is going to be WAN IP address is going to be 10.1.1.2, 255.255.255.252, and then no shut. We're going to bring the interface up, and then we're going to configure the LAN side, which is interface big 0/0/1. IP address is going to be 8.8.8.1, and that's going to be /24. So 255.255.255.0. Okay, cool. So we have done that. What do we need to do? Configure EIGRP. The syntax is router EIGRP 1. The autonomous system on EIGRP must match on both ends. And we're going to be advertising the network of 10.1.1.0, 255.255.255.252. And then immediately our neighborship came up. So you can see on this part that now my EIGRP neighborship has come up with router number 2. And I still have one more network to advertise, which is the 8.8.8 network, because I need the other side to know about that network via EIGRP. So I'm going to continue my configuration. Network 8.8.8.0, 255.255.255.0. We're almost getting there. All right, so how do I confirm that my routes are now in the routing table? I use the command show IP route to see if I've got EIGRP routes. And remember the last time I said EIGRP routes are denoted by a D. So we have an EIGRP route that has been learned, and it has been learned from 10.1.1.1.1. So these are the two routers. This is our one interface. So what this routing table is saying is I have learned about this network from this particular router, which is R1, and this is R2. So R2 is saying I've learned about the 192.168.0.0 network from R1. And if I have traffic that needs to reach that network, I'm going to send it in this direction. And if we go and do the same thing and look at the routing table on R1, we are going to see the reverse. And R1, got a yellow pen. Okay, there we go. R1 should then say, I've learned about the 8.8.8 network, and I'm learning it from R2. So if you want to get to that network, get to R2, he will take you to where you want to go to. So that is done. And then I think the last part that we need to configure is the, sorry, what happened? Did I not? Okay, so I think, all right. So I suspect, not that I suspect, my interface is not up on the LAN side. And how do I verify? Show IP interface brief. And you can see that my interface is administratively shut down. This basically means that the interface is down. I need to bring it up. If I don't bring it up, it's not going to come up. So how do I do that? I go into my config, interface big 0/0/1. Please, if I've lost you somewhere along the lines, this is the time to ask questions, and I'll be able to explain and come back to the concept. So I'm just going to do a no shut and then check one more time, show IP interface brief, and I should see up. What I want to see is up and up. That means my interfaces are good to go. So the last step to configure is going to be our server on the internet side, which is going to be our Google server per se. So we want to configure the IP address. So the first thing we're going to do is configure the IP address and say it's going to be 8.8.8.8. And the subnet mask, sorry, what am I looking for? Oh, sorry. Fast Ethernet. So the IP address is 8.8.8.8. And the subnet mask is 255.255.255.0. So that's a /24. And then the gateway is going to be 8.8.8.8.1. It's the IP address of the router. So now we have completed. Our lab should be good to go. So how am I going to test? to make sure that our lab is functioning, I'm going to go to this PC. Once again, I'm going to ping, but this time around, I'm pinging the server on the other end. Right, if I bring back our network diagram, I'll show you the test that I'm trying to conduct. Right, I'm trying to conduct. So what I'm doing right now is trying to ping from this PC all the way to the Google server. If I can ping that, it means this is fine, 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 and that is fine. And that's how you can use shooting from the hip as a methodology to be able to troubleshoot your issues. Hi, Wilson. Thank you for following. Before I lose my train of thought, so that's what you're trying to verify. So I'm just going to come back to that PC, and we're going to test connectivity. So PC 0. All right, let me erase that. Okay, return. Okay, so let's ping 8.8.8.8, and there is no reply. There we go. Right, so we got a reply. So I didn't want to start my troubleshooting from here, but anyway, so this is working, so we can get to that device. That's number one. Number two, we need to test our DNS. So we need to come here and open a web. And this is the beauty of Packet Tracer. You've got some of these tools. You can actually open a web browser in Packet Tracer and be able to test. So we're going to test DNS to make sure that our DNS is working. So remember, I said we should type google.com, and when I press enter or press go, click go, whichever the situation might be. Wait a minute, did I configure? Right, so that should be able to, okay, this is not resolving. Okay, let me try and put the IP address and see if that resolves to anything. I'm not so sure if I enabled. Okay, so the IP address is working. So I can resolve the IP address, but I'm having DNS issues. Let me just double check. So now we are starting the troubleshooting process. It probably came earlier than anticipated, but I'm not gonna start by doing this. I'm just gonna leave this lab, and we're gonna be looking at our first ticket. I created tickets that we can be able to then analyze. All right, so this is the first ticket. So you are working as the network engineer, network technician. You get a call. John is complaining that he cannot access the printer on the ground floor, and everything was working on Friday before he left the office. But when he came in the morning, the printer wasn't working. He mentioned that cleaners were in the office over the weekend cleaning the carpets. So I am going to break our network. I'm going to break it outside of this, and we are going to then troubleshoot, what might be the possible reasons why the network is not working. So I'm just going to go here. I'm just going to do something quickly. But whilst I'm doing that, just try and figure out, what you think might be the issue on why the printer is not working. Okay, I'm going to bring back my diagram. If you are smart enough, the solution is in the picture. But anyway, let's break it down. So coming back to our ticket, what is the issue? The users are complaining, or John is complaining, that he cannot print on the ground floor. On Friday, everything else was working fine, left the office, came back on Monday, and the printer is not working. Now, if you go back into our methodology process, we say that we need to gather enough questions, right? So I'm probably hypothesizing. What could it be? It could be maybe it's John's problem. Maybe John's PC is the one that's got an issue. And if we test John's PC to try and see if it can connect to anything, we'll be able to verify. So let's take John's PC, which is PC 0. I think I've got it somewhere here. Right, so we've got John's PC, which is this one. So let us confirm if John can access anything at all on the network, because we want to see if John's issue is related to only him or it's affecting other users. So the first step is I'm going to ping the default gateway, right? So 192.168.0.1, and John's PC can reach the default gateway. Okay, cool. Let's see if we can get to the DNS server, 192.168.0.10, and we're getting a reply. So you can get to the DNS server. So by method of elimination, if I were to draw the issue that we're experiencing here, we have John's PC sitting here. We've got the switch, we've got the router, we've got the DNS server, and then we've got the printer. Right, so because John can get to the DNS server and he can get to the router, there's a very limited chance that the issue is something to do with John's PC. The issue might probably be the printer. And we said the printer IP address is 192.168.0.50. So let us see if John can ping that particular IP address. So let's return ping 192.168.0.50. If I can get that right, .0.50. All right, so we're not getting a reply. So we're getting a request timed out. So clearly there's something wrong with the printer. So we have confirmed. But for good troubleshooting, we need a second computer to be able to verify. And we have two PCs in our network. So what are we going to do? We're going to go to PC number 2. And in the office, that will be some other user that you probably go and ask to help you troubleshoot. So we're going to go to PC number 2, and let us try and establish what PC number 2 is seeing and what it can and cannot do, right? For us to then be able to kind of get to a conclusion as to what the problem might be. So let us ping 192.168.0.1. We want to see if PC number 2 can get to the gateway. So PC number 2 can get to the gateway. Can it get to the printer? It can't get to the printer. So now we've got two PCs on the network that can't get to the printer. So clearly it's not a PC issue. It's not a cabling issue. So let's go and look at the switch to try and work out what is happening on the switch. So I'm going to close that and I'm going to open my switch, and then I'm going to bring it on the screen. I'm just going to erase this one. And then I'm going to just have a look. So one of my first commands that I type on a Cisco switch is show interface status. This command basically tells me which interfaces are connected and which interfaces are not connected. And from there, I can either make an estimated guess on what the issue might be. So the first thing, if I go to my diagram, I'll notice that the printer is connected on port number 4 on the switch. So I'm referring to this, I'm referring to this port. The printer is connected on port number 4 on the switch. So I need to figure out what is configured on port number 4. So I go back to my switch, just erase that, go back to my switch. And then I look at port number 4, just gonna bring my pen to highlight that. And my port number 4 is disabled. So you can see the port is disabled. Okay, port is disabled. What could be the issue? Now, if we were to go back to our ticket, and I've seen this happening quite a lot, the highlight that we got was that there were cleaners who were in the office. And there's a very high chance that someone was cleaning, decided to use the socket, where the printer was connected, but forgot to plug it back in. And because of that, the printer lost its connectivity. So in my case, if you were looking at the diagram, I'll try and return to the diagram. If you're looking at the diagram, you will notice that this port went red, basically signifying that there's no connectivity. So how would I fix it? In my case, I'm probably just going to config T on the switch, and then, or maybe not do that. Let me just, the next command that I type is show run interface FA04. Okay, that command doesn't run on packet tracer, so it's not going to work. Anyway, so I'm just going to do a conf T interface FA04. I'm going to do a no shut, and then that interface is going to come up. Our printer should be online. And now I'm going to go back to PC1 and try and ping the printer. And then I think the printer should come back in the next 15 to 30 seconds. And what's basically happening is spanning tree. The port is in a blocked state, so it has to go through listening, learning MAC addresses before it goes into forwarding state. So now it's green. If I go back to my PC, I should be able to then reach the printer, and now I'm getting a reply. So that was our first ticket. And this is how tickets come like in the organization. You're going to get users making requests as simple as a printer not working, and it is your responsibility to be able to troubleshoot and try and figure out what is the problem and how best you can fix that particular problem. All right, so we're going to close off our ticket number 1, and we said the issue was a power issue, right? So when you fix the power issue, then everything else was then resolved. So let us look at ticket number 2. Okay. Right, so ticket number 2, Susan has called that she cannot access the internet, right? And in our case, the Google server is what we are calling the internet. So Susan has called, she can't access the internet from a machine. She tried to go to google.com. Oh, okay. But she's getting an error. She also checked with other users in the office, and they're also facing the same issue, right? So from just what this ticket is saying is, this issue is affecting multiple users. And because it's affecting multiple users, it will be pointless for us to try and narrow down the issue on Susan's PC as the root cause, because it's affecting everyone, right? So automatically when it says it's affecting multiple users, don't waste your time trying to troubleshoot on one user. Try and think to yourself, if it's affecting everyone, what could be the problem, right? And then she also tried to access other websites, such as yahoo.com, but she's not having any luck. So in this case, internet is not working. So where do we start? I'm going to start by, once again, I always like starting at layer 3 because I want to see if I have reachability. So my favorite command, if you don't know by now, it's the ping command. That's my favorite command for 2 reasons. It allows me to see if I've got network reachability. If I've got reachability, I can take my next step knowing what my root cause might be. So going back to our diagram, my starting point is always going to be so this is Susan's PC 0. So I'm going to ping the internet, which is 8.8.8.8. Okay, so I'm getting a reply. So automatically I know that between my PC, which is sitting here, PC1, connected to a switch, connected to a router, connected to the WAN, connected to another router, and then going into another switch, and then going to the Google server, which is 8.8.8, I have reachability. So I have network connectivity all the way from here to here. The network can go all the way. That's what the ping command is confirming for me. So what could be the issue? Now, if you go back to our ticket, what are we told? We are told that she tried to go to google.com. All right, so let's open our web browser and let's see what's happening. Right, desktop, I'm going to close that. Let's open up our web browser and let's try and figure out, what's going on and try and see what could be the issue. All right, might be a bit slow. Okay, so let's type google.com and press go. Okay, doesn't seem like a response is coming through. Okay, so for now, my suspicions is I have DNS issues. And why do I say that? Because I have a DNS server that is sitting on my network, and this DNS server is the one that is resolving my fully qualified domain name, google.com, to my IP address of 8.8.8.8.8. So if this DNS server is not working, then there's no way I'm going to be able to reach this web server on its domain name. So how do I verify? I'm suspecting the DNS issue. How do I confirm? If I were to put an IP address in the web browser and I resolve that IP address and I get the web page coming out, then I will know that I have a DNS issue. So let's give it a shot and see if that's going to resolve our problem. So you see, hostname is unresolved. So I'm going to put the IP address because I can ping the IP address. So I have network reachability, but I'm suspecting I've got DNS issues. So I'm going to put the IP address 8.8.8 and I'm going to press enter. And then all of a sudden, my web page comes up. So this basically confirms that there's something wrong with my DNS. So I have to go and look at my DNS server and try and see what I might have missed in that whole configuration process. So let us look at our DNS server. I'm just going to return that. Just going to minimize. All right, just hold on. Okay, let's take a number 2. Come back. So let's look at our DNS server. Let's look at the configuration of the DNS server. So we say DNS. So we do have google.com. The host A record is there, 8.8.8.8. And the SharePoint.com is 192.168.0.10. Okay, so let's test to see if this PC can get to SharePoint.com. So SharePoint.com. Let's go. Okay, so SharePoint.com is also not working. This is interesting. All right, that's fine. So let's go to our server. So DNS record. There we go. There we go. So our DNS service is off, right? I have to turn it on. It's currently off. And if I turn it on, we should then be able to resolve. But before I turn it on, I want to show you one more command that you can use to verify your DNS as the root cause, right? I started from the web browser. It's a good way to do it, but it's not the best way. The best command to verify any DNS issues is a command known as nslookup. So if I go back to PC1 and then close that, we'll open it. Just come back to this part. So if I do an nslookup, just going to press enter. So nslookup, and I'm looking up for google.com. nslookup is what resolves my host name to IP address. And this is going to fail. It's intentional because I want us to come back to this command after we have enabled the DNS service and then be able to then verify. So our DNS request currently is timing out. Right, so we need to then fix DNS and then come back and have a look at this command and see if that then fixes the issue. So if you come back here, we are going to turn on, I'm just going to erase this. We're going to turn on our service. So DNS has now been turned on. And then I'm going to go back to this command, nslookup, and I'm going to press enter. And now we are now resolving. So google.com is now resolving to 8.8.8.8. And then SharePoint.com should resolve to 192.168.0.10. Let us confirm. So let's do an NS lookup of SharePoint.com. And now that is resolving to 192.168.0.10. So let's now go back to our web browser, because remember, our objective is to get the web browser functioning. So let's go back to our web browser on this PC and see if we can now access the web server on the google.com URL so that we can fix Susan's issue. Sorry, that's taking a bit of time. It's crashing up a little bit. All right, there we go. So let's go google.com and press go. And then now we have resolved our web page. Let me just make this bigger. So now we have resolved our web page on google.com instead of the IP address. So let us take a step back and just explain what has transpired, just so that we're not rushing to fix issues, but we are making sure that we understand the concepts behind and what it is that we are working on achieving. Okay, so I'm just going to make sure. All right, so I'm just going to take a step back on our tickets. I want us to go back to the diagram so that we can be certain. I can explain what has transpired. Okay, so I'm just going to pick up my pen here. So this PC is using this DNS server to resolve the pen google.com fully qualified domain name to the IP address of 8.8.8.8. So the packet is coming this way, querying the DNS server first, and then after that it gets a response, and then from there it knows that it needs to go to this particular server to then find the server that it's looking for. And in our situation, this DNS server wasn't functioning, and therefore there was no way this PC would know how to get to the server because it did not have the IP address. So that's what we basically did by fixing this particular server. So I just wanted to just explain that. So let's go back to our ticket and let us see if we have resolved the issue. Okay, so now we have confirmed that we can now get to google.com, and assuming that if Yahoo was in the DNS resolution, would also be able to then get to it. So now we have fixed ticket number 2. Let me just come back to, yes, and just double check. Guys, if you got any questions, this is the time. If I've lost you somewhere along the lines, you're like, please rewind and explain again. I'm more than happy to explain again. But if you're good, then we can basically continue. So we've done 2 tickets. The first issue was a physical issue for the printer. The second one was a DNS issue. Let us look at ticket number 3 and let's try and figure out what might be the problem. Now I'm going to challenge you to, okay, where am I? I'm going to challenge you to try and read the next ticket and come up with what you think might be the problem, right? So based on this, then we're going to go through together and try and see if what the issue is what the issue was. Whilst you're doing that, I'm just going to break my network one more time, and then we can then be able to troubleshoot. Okay, I'm just going to pull that offline. Okay, what happened? What happened? Okay, there we go. right, let's look at the issue and let's try and break down based on our methodology of troubleshooting. So you have received a call from 5 different users, and they're all complaining that they cannot access the network. So 5 different people all complaining about the same thing. Okay? They noticed that when they came into the office in the morning, all printers, IP phones are also done. So they're also down. Nothing is working. You are not aware of any maintenance or electrical works that are scheduled. So why the maintenance and electrical works? Maybe sometimes there might be some works taking place in the office that might be causing this particular issue. So 5 users complaining about the same problem. They can't access printers, the IP phones are down. Now, by basically looking at that, maybe, can I take a top-down approach? Is it going to work? Maybe not, because top-down approach says I'm going to start from layer 7, right? So I'm going to go to the web browser, and web browser, then what am I going to do? I'm probably going to type google.com. But remember, the issue is not an individual. It's 5 users that have called so far. So then you have to go to 5 different web browsers for you to then try and verify. So maybe the top-down approach might be too slow in trying to fix this issue. And maybe you might want to take a bottom-up approach. Right, so bottom-up approach is starting from the physical layer, and the physical layer is looking at the cable between the PC and the switch. But because it's 5 different users, it's very rare for 5 different cables, to all go down at the same time in the same morning in one office. I'm not saying it's impossible, but it's very rare. So if we can't find the problem on layer 1, where do we go to? We are going bottom up. So we're going to go into layer 2. And which device operates on layer number 2? A switch. So a switch is the layer 2 device. So we need to verify, is our switch on or off? Because if our switch is off, that will probably explain why every user is affected. But the switch being on and off might not give us a full story, because the switch might be on, but it lost its config. And thus, users don't have a VLAN, because there was a VLAN that was once configured on the switch. That VLAN is no longer there. So therefore, the user can't then access the network. So the switch being on is not an indicator that everything else is fine. We need to then go a step ahead and then try and figure out. Now, if we go back to our diagram, I'm sure we'll probably be able to notice what might be the root cause. You notice that all of our interfaces coming from the switch are all showing red, which means that there's something wrong with the switch, because all the devices of the network have basically gone down. So if you look at, I'm talking about this section, right? If you look at this, there's red, there's red, there's red, there's red, there's red. So anything that's connecting to the switch in either direction is red. So the likely possibility is we need to look at the switch to try and figure out what is happening with the switch. So I'm going to go to the switch. I'm just going to pull the switch interface. Sorry, the switch. Yeah. Just going to pull that, and then I'm going to press enter. Remember, my first and favorite command on any Cisco device, mainly switches, is show interface status. I love this command because it gives me a snapshot of what might be the issue. So by merely looking at the status, I notice that port 1 up to 10 on this switch, they are in a disabled state. Right. So I can type that command. The other command that you can type, though it's going to take you a bit longer to find out the root cause, is show running config. And if I show running config, you notice that my interfaces from F04, the interface is shut down, shut down, shut down, shut down. So because all these interfaces are shut down, now remember the switch is on, but the interfaces are shut down. So earlier on I was saying that just because the switch is on does not mean that the interfaces are functional. You need to then go into each and every interface. In this case, the issue was the interfaces have been shut down, but in some instances, it could be that this port is in VLAN 10, and this one was configured into VLAN 20 by mistake. And because of that, this port stopped working because it's in the wrong VLAN. So you need to go to the switch to try and figure out. I guess in this instance, I was just trying to demonstrate a switch going off, but because I'm using Packet Tracer, I can't turn off the switch. So I just shut down the interfaces to be able to simulate the same thing. So how do we fix this particular issue? Whilst on the switch, I'm going to type conf t to get into a configuration, and I'm going to type interface range, fast Ethernet 0/1 up to 10, and I'm going to do no shut. And then all these interfaces are going to come back online. And now my network should start becoming functional. Once again, spanning tree is taking place. Just a side note. So if I show spanning tree, you notice that I've got my ports that are in a learning state, right? So spanning tree, remember we said there are multiple states. A port starts being blocked, that's step number 1. And then it goes into a listening state, and it goes into a learning state before it goes into a forwarding state. Right, so this is the process of spanning tree. And so far they are in learning state. When I type the same command after, you're going to see that these are going to change and go into forwarding mode. So I'm just going to do an up arrow. And then now they are in forwarding mode. So now they are forwarding traffic. And if I go back and look at the diagram, my ports are now green in color. So spanning tree is always going to be visible in Packet Tracer. If you've got Packet Tracer, you can build this lab and walk with me each and every lab that we're going through and be able to implement it on your own. I always encourage people, the only way you're going to learn is when you practically configure and practically break your network and be able to fix it. That's the only way that you're going to learn. There's no other way. I get so many questions, people asking, how do I get on hands-on experience? This is the hands-on experience. It doesn't get better than that, right? You don't need the physical devices. Not all of us can have physical devices, number 1. Number 2, they're not practical. I'll just give you an example. You see, I've got a router that is sitting here. I'm probably not visible. I'm just going to get... I just want to show you that it's not practical to be configuring. Look at how heavy this thing is. How many times do you think I'm going to power this on? I'm probably not going to power it on, I'll probably power it on when I really need it, but most of the times I'm not going to power it on because it's too much work, trying to get this functioning. So virtual labs are the way to go. They'll give you everything that you're looking for. To welcome. What's going on? We are doing network troubleshooting, and we have a network diagram that we are working through, and we're having tickets that have been sent to us for us to fix. So we have got 2 more tickets that we're going to look at. But if you've got any questions, please don't hesitate to let me know. Right, so we have fixed that particular issue, let us see what the next ticket is asking. So ticket number 4. This is a very long ticket, so I'm just gonna try and make sure that we read. So when you get a ticket, right, try and look for keywords. Like if someone came to you and say that I'm sick, right, you're probably gonna ask, is your temperature high? What are you feeling? Is it a stomach issue? Is it a headache? Is it your leg? And you can't come to me, limping and like, hey, my leg is sore. I'm like, you got a heart disease. Like, how do I correlate the leg being sore and a heart disease, right? So similar thing. Okay, let's go to our ticket. So due to COVID, the office has downsized and its space is downsized its space and introduced hot desking. So for those that are not aware, hot desking is when in your office, no one owns a desk. You book a desk, depending on which day of the week. So today you might be sitting here, tomorrow you might be sitting somewhere else. It just depends on what desk is available. Okay, cool. So different teams coming on different days. Susan from the HR department is using PC number 2, okay, as a hot desk for the day. She noticed that she cannot access the internet, but she has no issue accessing local corporate SharePoint site. So she can't get to the internet, but she can access the local SharePoint site. She can also print without any issues, but cannot access the internet. She is not sure if this is if this computer used to work before, because she's using this computer for the first time. Okay. So for those that have joined us and are not aware, I'm just going to bring back the network diagram in question so that we can be able to be on the same page. Right, so this is our network diagram. So Susan is using this computer here, right? She can't access the internet, so she's failing to get here, but she can get to the printer, she can get to the local SharePoint server. So based on this network diagram, where do you think the issue might be, right? Is the issue here? Is it here? Is it here? Is it here? Or is it here? There are multiple points, right? Because if this interface was down, it means that there's no way she can get to this side of the network, which is where the internet is. If this interface was down and this one was up, she will not be able to then do. So our job is to troubleshoot. So whilst you're thinking about that, I'm just going to make 1 or 2 tweaks on the network, and then we can then try and work out, which method do we use to do our troubleshooting. All right, just bear with me. What do I want? Okay. What do I want? I didn't want this to be here. Anyway, it's here, doesn't matter. Nonetheless, let's go back to our diagram. All right, so where do you think we should start? Do we start with this PC? Should we check if this PC can ping this IP address? That's one way. I always like starting from layer 3. That's my default starting point. So I like using the ping command. I try and ping this device. If I can ping the device, I know that all the way from here, everything else is working fine. So let us verify and see if we are coming to the same conclusion. Okay. So back to our diagram. This is PC number 2. Where is my cursor? Okay, so PC number 2, let's ping the default gateway 192.168.0. 8.1, and we're getting a reply. So it means from our PC getting to the default gateway, everything else is working fine. Okay. What other command can we use to test, what the issue might be? I'm going to introduce a new command that we haven't spoken about, and that command is called trace route, but it is spelled as trace RT. Right. Trace route basically measures the hops that your device takes to get to the destination, or in simple terms, how many routers it goes along the way. So what trace, I'll draw this and then we'll probably walk through. So this is my router. This is the router along the path, another router along the path. So when I run a trace command, it's going to say, I can hop from here to here. I can hop from here to here, but I can't hop from here to here. And because I can do this hop and this hop, it means that my issue is likely on this link facing the last router that I could get to, right? So that's what trace route basically gives you. So in all cases, when I run it, the last device that responds to me is the last device that I can get to, and I can't go beyond that. Then I can then go and troubleshoot what might the issue might be. Thank you very much, Albert. Yes, the official method of starting from layer 3, it's called divide and conquer. Thank you very much. Yes, it's called divide and conquer. So I call it shooting from the hip, right? You just try, but it's called divide and conquer. So you divide and you either go up or go down to try and troubleshoot your issue. All right, so let us run our trace command to 8.8.8.8, and let's see what it returns. So I'm going to press enter so we can get to 192.168.0.1. Whilst the trace is running, I'm going to bring back our network diagram. Right, so this is .1, right? So .1 is this interface here. Just going to put it. So this is .1. So this PC is saying I can get to .1, but I can't get beyond that, right? So I'm getting to .1, not an issue, but I can't go past .1. So where then do I go and focus my time? I can't focus on the switch because it can go past the switch. So I have to go and focus my eyes on the router. Now, remember, I say to you, when you are hypothesizing, try and ask yourself, when I get to the router, what am I looking for? The first thing I'm going to be looking for is the interface status, right? Is there anything down on the interfaces? The second thing I'm going to be looking at, routing, right? Is my route of 8.8.8.8 in the routing table? That's number 2. Number 3, I might be looking at the routing protocols. Right. Do I have any routing protocol that is giving me my next hop to my destination? Number 4, I might be looking at, maybe not covered much in Network Plus, but in some instances, you might have ACLs or access lists that are blocking your traffic. So yes, the route is there, the interfaces are up, the routing protocol is functioning, but the ACL is blocking your traffic. So you need to look at all these options. So when you go to a device, try at minimum have 5 possible problems that you're trying to fix. We do this in real life, right? If you get a phone call and someone says, hey, can you come and help me? My car is not, let's say, I might be crucified for this example, but I'm going to give it nonetheless. Majority of the times, the female gender is not very familiar with how cars function. So I want you to picture your sister calls you and says, hey, I have a breakdown. My car is not starting. And she's probably 100 kilometers out of town. You need to figure out what are you going to carry, right? So you need to say to yourself, could it be a fuel issue? If it's a fuel issue, I need to carry fuel. If it's a battery issue, I need to carry jumpers. If it's, whatever you might think the issue, if it's a flat tire, I need to carry a spare wheel. So when you're going to help, you're not going to go empty-handed. You're going to ask questions. What is the problem? Are the tires okay? When was the last time you put fuel? You're gathering information. Okay, so let's go to the router and let us try and see what we can observe. And when you get to the router, we're going to be looking at these 4 items that I've mentioned, and we're going to be seeing how we can verify the 4 items. So let's go to the router and let us see what is taking place. All right, get that done. So you're going to go to router number 1. So I didn't label it. Let me just change the host name to R1 so that we are consistent. Okay. So I didn't put the router at the side. Sorry, my apologies. I've been working with it on the other side. Okay, cool. So we've got R1. So what are we looking at? We want to see the interface status. So show the syntax on the router is different. You don't type show interface status, you type show IP interface brief. So show IP interface brief. Show IP interface brief. Okay, cool. So it says I've got 2 interfaces. Remember, my connection looks something like this. From R1, I've got 2 interfaces. One is going to the LAN and one is going to the WAN. And we said the one that's going to the LAN is gig 0, 0, 0, and the one that's going to the WAN is 0, 0, 1. So the one that's going to the LAN, we are told that it is up, and up meaning the status is up, the protocol is up. The one going to the WAN is administratively shut down, meaning the interface is down. That might be our issue, but that's not what I want to focus on. I don't want to narrow down too quickly. We said we're going to check the interface status. Just hold on. Interface status is the first thing we're going to check. We're going to check the routing table. We're going to check the routing protocol, if we have any protocol running. And we're also going to check maybe not ACL, but anyway. So, because I want us to go step by step so that I can show you how I would attempt this in a real live production environment. So I've seen that the interface is down. Okay, I suspect that's our problem, but I don't want to narrow down too quickly. So what else can I type? I'm going to check the routing table. Right, so I'm going to type show IP route. This is the command that shows us the routing table. So I can type show IP route as a generic command. It's going to give me the entire routing table. And then I'm going to look for my destination network because I must find it in the routing table. So I'm going to be looking for 8.8.8.8. When I look at my routing table, I can't see that subnet. So the first command is show IP route. Fantastic. The other command that you can type that is more specific is show IP route, and then put the actual subnet that you're trying to find in the routing table. So I'm going to show IP route 8.8.8.8 and press enter. And you're going to see that I'm getting an error that says the network is not there we go, this one. We're getting an error that the network is not in the routing table. This is your indicator that you got a routing issue because it clearly tells you that it's not in the routing table. By default, routers drop traffic that they don't have a route to, right? So what is happening here? We have R1. I'll draw it again so that we can see it much more clearly. R1, R2. A packet has made it to R1 with a destination of 8.8.8.8. it gets to R1. R1 looks in his routing table and he says, I don't know what to do with this packet because I don't have a route to the destination. So what is he going to do? He's going to drop the packet. So he needs a route. We're going to fix it, and we're going to come back and then look at that route in the routing table to see if it now exists and see how the routing table looks like when the route actually exists. So the third step is the routing protocol, right? So the absence of a route does not mean that the routing protocol is non-existent. Because remember, when I configured EIGRP, I had to advertise the route so that the other router could learn about it. So you might have a routing protocol, but if you don't advertise the subnet, there is no way the other device might find out about it. So we need to then check what routing protocols are configured. Remember I think 4 weeks back, we looked at routing protocols and we spoke about something known as administrative distance. And we said that different routing protocols have got different administrative distances. EIGRP has an AD of 90, OSPF has an AD of 110, and RIP has got an AD of 120. And we say that the routing protocol with the lower AD is the preferred route. And we say that a static route has an administrative distance of 0, or 0 is connected, static route is 1. So if you've got a static route and an EIGRP route, the static route is going to be preferred. So sometimes you might have a static route pointing in the wrong direction. It's not that it's not there. And the static route is going to be preferred versus EIGRP, that might be correct because the static route has got a lower administrative distance. So I'm just going to erase that, come here, and then we're going to close off by looking at the IP protocols to try and see if we've got any routing protocols configured. I think we typed this command earlier on, and this confirms that we have EIGRP running, and we are advertising these two networks, right? So we are advertising those networks. If you don't see anything here, it means that your protocol is running, but you're advertising nothing. So because you're advertising nothing, there's no way the other end will get to know about your network. So coming back, the issue in our situation is that the interface is shut down. So I'm going to do a no shut, and then we're going to see the routing table populating and everything else then showing up. So we're just going to come back and then press enter, conf t, interface gig 0/0/0, 1 no shut. All right, so immediately I brought back that interface. Our neighborship between R1 and R2 basically came online. So now we've got neighbors. Now I need to check the routing table to see if I can now see that particular route. Coming back to check my routing table, Control C, show IP route, that is the command. And now I now know about the 8.8 network. And where am I learning it from? I'm learning it from D. What does D represent? EIGRP. So I'm learning this route from EIGRP. AD is 90, because that's the administrative distance for EIGRP. Who is my next hop? 10.1.1.2. Who is 10.1.1.2? If I were to minimize this and go back to our network diagram, this is the next hop. So what this is simply telling me is that this router has learned about this route from this R2 via EIGRP. So now that is sorted out. What was our ticket saying? Because remember, we always have to come back to what was the objective of the ticket. The ticket number 4 is she can't access the internet. Now, if you go back to PC number 2, which is what Susan was using, we should be able to then double check if internet has been restored. So that's PC 2. Okay, so earlier on, when we did our trace was failing on 192.168.0.1. Now, if we run the same trace, We want to see where it takes us. Now, all of a sudden, our trace is now going past. So we are now hopping from the PC to router 1, from router 1 to router 2, and then router 2 then takes us to the server that is sitting here. So trace route allows you to then trace the path and try and see where the issue might be. So I want you to picture trace route in simple terms. You got your house and this is your bathtub, right? You try and take a bath, you try and open the tap, but there's no water that's coming. So what do? You check the pipes outside that supply the water. If the pipes are fine, you go and check the supply source in the street. Right, so you're basically hoping until you get to the point where, oh, by the way, the pipe here is burst. That's where you've got an issue. That's why you don't have water. That's the same thing with trace route. You're basically just going down the line and verifying. All right, any questions? I assume everything else is fine. You know, I get people saying following, fantastic. No questions. We're going to look at ticket number 5. That's our last ticket. And then we're going to recap, what it is that we basically covered. And then I'll answer any question if there are any questions that might arise. So ticket number 5. Due to COVID. Oh man, why do I have a feeling that I fixed this issue already? Anyway, due to COVID, the office has downsized its space and introduced hot desking with different teams coming on different days. John is hot desking and noticed that he cannot access the internet from the PC. He tried logging on to PC 1 on a different desk, but had the same issue. When he tried to run the traceset command, he got the below output. Now, this question is a question that is a very good candidate of a question that will come in the exam. Why? Because they want to know if you understand the output of a traceset or a trace route command. And in this case, they gave us a trace route command. And they're simply saying, if you had a trace route issue, you look at the last device that you're getting to. And that is the device that you go and look into to narrow down where your issue might be. And in our case, we're going to be going to router 1 because that is where our trace is basically stopping. So ticket number 5, we basically fixed it in the previous, the last, what we did just now is what was happening with ticket number 5. So we basically looked at 5 different tickets, that you're likely going to encounter as you work in the industry. So before I get to that part, the reason why I always encourage people to do labs is there is no way you're going to know what the output of a traceset command is going to look like if you've never typed it. But when you've typed it and you've troubleshooted an issue that was as a result of trace and it helped you to find the solution, you're not going to forget it. Why? Because you've used it in real life. And real life does not matter. It can be a lab. And I've always said this, and if anyone is listening who's trying to break into the industry and you're going for interviews, but you're not probably getting a job and you're wondering what's going on, I always say to people, build your lab. I'm going to come back to our lab. I'll come back to it in 2 ways. I'm going to come back to the diagram to start with because I want to make a point on the diagram. So the diagram is, so this is our network diagram, right? I would rather have someone coming into an interview with a diagram that looks like this and explain to me what they did, what they configured, what protocol they used, and how they managed to get this to work. Why? Because this is what you're going to encounter in a real life environment, but at a bigger scale. We are always going to be connecting printers. We're always going to be connecting users. We're always going to be connected to gateways. We're always going to be connecting to switches. We're always going to be connecting to the internet. The principle doesn't change. Having such a diagram simply then demonstrates that not only do you have the passion to want to learn, but you are able to document, because from this diagram, you can actually tell me multiple things. In this troubleshooting exercise, we looked at 5 tickets, right? The first issue was a physical issue, right? We had a physical connectivity issue. The second issue was the DNS issue, just in this small lab. The second issue was the DNS issue, where DNS wasn't working. I think the third issue was a port issue on the switch. The fourth issue was a routing issue, right? An interface of the router was turned off, or it could be a routing protocol. And I think probably the fifth issue, which you didn't probably troubleshoot, is this interface might be down on the other end of the network that we don't control. And this could be a remote issue. So from such a simple lab, you are touching on very key concepts. We also looked at spanning tree along the lines. So we had spanning tree also involved in that whole process. We looked at gateways, how to configure a gateway and why a gateway is very important. We looked at routing protocols. Right, so before I start whinging too much, I guess the point I'm just trying to make is, from this simple lab, there are so many concepts that you can unpack from there and learn and understand and take that knowledge and bring it into an interview. And if you could, even if you could just sketch this network diagram as is, walk into an interview. Oh, sorry, we actually dealt with subnetting as well, right? We dealt with subnetting because we're dealing with this subnet, we're dealing with this subnet, we're dealing with this subnet. Ultimately, I could have made a misconfiguration and put one of these IP addresses in the wrong subnet. Things will start breaking, and it can actually break for everyone else. For example, if the gateway is in the wrong subnet, everyone else is going to get impacted. We could also test VLANs in all this. So just a simple lab, 2 PCs, 2 servers, 2 routers, 2 switches, and a remote server allows you to test probably more than 10 concepts, that you and I will encounter on a day-to-day basis from a network perspective. So this is the logical diagram. Remember last week or the week before, we looked at the physical diagram and the logical diagram. This is a typical example of a logical diagram that gives you a high-level overview of what your network looks like, what devices are there, what are the IP addresses of that particular network. And for those that were late, this is what it looks like in, I'm going to erase this. This is what it looks like in Packet Tracer, simple lab, nothing too fancy. I would encourage you, if you can, build this lab on your own, follow step by step what we did. Try and break it, even though what you might have changed to make it stop working, but try and break it and try and bring it back. And by so doing, you'll be able to practice, learn, get the practical experience. That is for those who don't have the practical experience. If you have practical experience and been working in the industry, then this was a walk in the park. But once again, the objective of learning is to improve, right? You might have learned something different that we did in troubleshooting that can help you in your next, troubleshooting quest. For those who don't know what it looks like, a day working as a network engineer or network technician, this is just a typical example of what you are likely going to be doing. So if you're thinking of becoming a network engineer and you're wondering, what do? We get tickets, and we get tickets, and we get tickets. The tickets might come via email. They might come via the help desk. Network teams usually are escalation points. Something from service desk is not working. They come to the network team. Hey guys, network is not working. We deal with tickets. And I told you, they call it tickets or they call it BAU. So sometimes you're probably going to find when you go or look at job descriptions, they'll say something like BAU. What they're basically referring is business as usual, meaning managing your network. The only difference is that we've got fancy monitoring tools, that give us, very good statistic data that can help us analyze and manage our networks. But at the bare minimum, this is what we do to fix networks. So I don't know if anyone's got any questions. Thursday is going to be our last lesson. And on Thursday, I'm going to be looking into some of the commands that I looked into today, things like the ping command, traceset, NSLOOKUP. We're going to be looking at other tools that you can use to be able to manage and monitor your network, things like IPEF. We're going to be looking at things like Wireshark. Why do we need it? Where do we use it? We're going to be looking at Wi-Fi analyzers. So you're going to be looking at a whole lot of, tools that can help you as you go into the industry, but also commands that can also help you to establish, what might be the problem. And then also we're going to do some configurations. So I'm going to probably line up, spanning tree, VTP, just a number of labs. Objective is we have as much practical experience as possible so that we can take this and be able to use it in the industry. I don't know, going once, going twice, are there any questions? And when I mean any question, I mean any question related to networking, or maybe not related to networking, but preferably a network question that you might want to ask. There's no silly question. There might be a concept that you might have not understood, not from what we've covered today, but a question that you've just had in general that you might want someone to be able to explain. This is the chance. If there are any questions, I'm probably gonna just stick around for another minute or two to find out if there are any questions. If there are no questions, fantastic. But yes, it's been an interesting journey. I'm talking to someone to collaborate on Security Plus. So I might be posting information in the near future that, on this channel, same like this one, we will then do Security Plus. There are plans to also do CCNA and cover CCNA in almost a similar manner. The whole objective is sharing information, as much as we can. And yeah, those that might need some form of mentorship, I haven't fully defined what that mentorship looks like, but from my end, I am more than willing to be your accountability partner. Right, let me put it that way. Accountability partner. And how do I envision that working? Right, you get in touch with me, we have a conversation, and we come up with a plan. And the plan says, in the first 3 months, I want to get A+. In the next 5 months, I want to get Network Plus. In the next 8 months, I want to get CCNA. Right? We come up with a date. Okay, 5th of January, 5 Jan 2023. If I'm still alive, I'll give you a phone call and say, hey, do we have A+? Then you say yes, or you say no. If you say no, what's the problem? I'm not there to judge you, but I'm just there to ask you questions and help you to be accountable. So at least when you got someone that you're accountable to, you might, some people do well when they've got people that they are accountable to. You might come to me with a concept that you might be struggling to understand. I might take that concept and then teach it to everyone. I might be teaching it to you directly, but it'll be for the benefit of everyone. So that's how the accountability mentorship path is currently working. Or you might come to me and say, hey, I need advice on a career path. Right. I want to be network engineer in 4 years. How do I get there? Then we work out, okay, let's try going this way and going that way to get us to where it's never a straight line, right? There's no straight line in the industry. We all choose different paths to get there. You know, we work out, where are you working? How old are you? You know, how are you young? Are you old? Because all these things are variables that are going to affect your entry into the industry. Which country are you in? If you're in Australia or in the US, probably the UK at the moment, this is the best time to be in IT because there's a shortage of skills. I get emails on a daily basis from recruiters that are saying, hey, you've got a job here. Are you interested? You've got another job here. Are you interested? I have to say, no, I'm not available. You know, I'm not available. Not now. You know, let's talk in 6 months' time. Maybe I might need you. Maybe I might not need you. The point is, you know, if you're in Africa, you know, what can we work with in an African context? How do we get you from where you are and where you want to be? Right. I'm not saying there's a magic bullet, but I'm just saying we'll sit down, make a plan, and then work through together. Right. So I'm dedicating my time to do that. But if you don't come and ask, it's fine, not a problem. But I'm just saying, if you need that help, it's available. My email address is in the description below. Shoot me an email. For those that have sent me emails, I've responded. Some I'm yet to respond. And yeah, even if you're watching this after the live recording, just send me an email. Let's have a chat and let's see how best we can help one another. Right, so that was my rant post this class. Once again, thank you for taking your time. And I will see you in the next one. That is going to be our last class. It's not going to be the last time me being online, but it's going to be our last class for Network Plus. Once again, thank you very much, and I'll see you in the next one.